So in lesson 8.5, we're going to be dealing with products with radicals, meaning we're going to be multiplying with radicals and simplifying. Now first, let's look at this box. This box we're going to be using a number of different ways in today's lesson. So let's make sure we understand what it's telling us. So both of these rows, both of these sets of information are really saying the same thing, just that in this first row of information they have this using powers or as a rational exponents, and in the second row they're dealing with radical form. But again, they're both saying the same thing. Looking at, let's look at the bottom one, that might be easier. Looking at this bottom one, what the left side is saying is that if I have the nth root of x times y, if I wanted to, I could break that up to be the nth root of x times the nth root of y, because sometimes that might make it easier for me to solve the problem. Or sometimes I might have something written that's on the right, like in the next couple of examples, where I have the nth root of x times the nth root of y, which maybe in that case it might not be very easy for me to simplify it, but since they're both the nth root, I can put them all under one radical, saying the nth root of x times y. So like I said, let's use this now for these examples. So in this example it says, calculate the cube root of 50 times the cube root of 20 without a calculator. Now I'm not sitting with you, so I don't know that you're not necessarily using a calculator, but I will be able to check to see how well you've done with this on the quizzes and on the tests, because there will be questions where you'll have to do these without a calculator. So please don't do yourself a disservice by pulling out a calculator and trying to do this quickly. Okay, so to simplify this problem, I don't know what the cube root of 50 is, and I don't know what the cube root of 20 is. So right now, the way it's set up, it's really not helping me too much. But let's see what would happen if I use this information that we just talked about and multiply, since these are both the cube root, multiply these together and see if that helps me simplify this without a calculator. So when I multiply those together, again, since it's the same root, it's going to stay the same root. So we don't multiply the roots together, the root stays the same. And 50 times 20 is 1,000. So remember what the cube root of 1,000 is asking us. It's saying what times itself 3 times would give me 1,000, which I can do in my head. 10 times 10 is 100, and 100 times 10 would be 1,000. So 10 cubed would be 1,000, so my answer is 10, because 10 times itself 3 times would give me 1,000. I just did that without a calculator. Now we're going to do this one together without a calculator. This one, it says a cube root of 320 times a cube root of 25. Well, that's pretty big to do without a calculator, so you're going to have to do this old school method. I know a lot of you guys did this or learned how to multiply using the lattice method, so let's use that. So I'm going to multiply, let's see, it'll be 320 times 25. And those of you that aren't familiar with the lattice method, what you do is you basically set up this grid. Notice how 320 has 3 digits, obviously, and 25 has 2 digits. So I set up a grid that's going to be 3 by 2. And now I put these diagonals, thus making it look like a lattice. And what I do is I multiply 0 times 2. Well, 0 times 2 is 0. And what I do is I put a 0 in both of those sections. 0 times 5 is also 0, so I put a 0 in both of those sections. Don't do anything else yet. We're going to fill up this whole grid here before I do anything else. So 2 times 2 is 4. Now 4 represented as a double digit would be written as 0, 4. And 2 times 5 is 10. So I'm going to write this as 1 and 0 there. 3 times 2 is 6. And 3 times 5 is 15. Now what you do with each of these lattices, each of these diagonals, we add up the numbers in that lattice. So in this lattice here, that's what I'm referring to, I just have the number 0. In the next lattice, I have the number 0. In the next lattice, what I'm doing is I'm adding these numbers up. 5 plus 1 is 6, plus 4 is 10. Now I have to carry the 1 over to the next lattice. So Now I add those together. 1 plus 6 is 7, plus 1 is 8, and then 0 is going to be in the last lattice. So when I take 320 times 25, that gives me 8,000. So the cube root of 8,000 is what I want to simplify. Now, one way to do this is by doing a factor tree. Now remember, this is the cubed root, so I want to figure out what times itself 3 times to give me 8,000. Well, when I do this tree, I know that 8 times 1,000 would give me 8,000. Since I'm dealing with the cubed root of 8,000, I'd be dealing with the cube root of both of these. So this is just one way to do this. And it turns out the cube root of 8 is 2, because 2 times 2 times 2 gives me 8. And we just talked about the cube root of 1,000 is 10. And 2 times 10 gives me 20. So the cube root of 8,000 is 20. And again, if right now, if what we just didn't make any sense to you, we're going to be doing a number of examples like this, so you'll get the hang of it. Let's look at the next example. Here I have the fourth root of 5x times the fourth root of 125x cubed. Again, I'm going to multiply 5 times 125, which you can use the lattice method for that. And when you do that, you end up getting 625. So I have the fourth root of 625. Now when I multiply these, x times x is x to the fourth. Now that's just one way to do it. One thing you could have done is if you didn't want to have to take 5 times 125, you really don't need to. Because what we're going to end up doing is we're going to end up doing a factor tree for this. Well, if I knew that 5 times 125 was going to end up being some number, I don't know what that is, I can just start by saying, well, my factor tree is going to be 5 times 125, because I'm going to be multiplying these two numbers together. And that x to the fourth is going to come into play here in a minute. Well, 5 is a prime number. Now, when I do a factor tree, anytime I come across a prime number, I circle it, because that helps me remember to include it in my final answer. Now, 125. I want to think of two numbers that multiply together to give me 125. Well, I know, since it ends in 5, that 5 is going to work. And it just so happens that 5 times 25 gives me 125. 5 is a prime number, so I'm going to circle that one. 25, well, that's easy. 5 times 5 gives me 25. Both of those are prime numbers, so I'm going to circle those. Notice how I'm left with 1, 2, 3, 4 5s, and it's asked me to find the fourth root. Oops. It's asked me to find the fourth root of this answer. So for every 4 of the same number, I get to factor one out, or take one out. So my answer is going to be 5. And now I have the fourth root of x to the fourth power. Now notice how 4 goes into 4 one time. So that means I can factor out 1x. I'm not left with anything under the radical, so my answer is just 5x. And I might be saying, well, how is it that that worked that way? Let's look at an example that's not on here. Let me move this up. Let's say if I had the cube root of x cubed. Well, remember the cube root says what times itself 3 times would give me x cubed. Well, x times x times x would give me x cubed. So my answer would be x. Or just like I said a second ago, I could divide these. The power divided by the root. 3 divided by 3 gives me 1. So I'd have x to the first power. Hopefully this is helping. Let's look at the next example. If you want, why don't you go ahead and try this one on your own, and then pause this video and then play it once you're ready. Or if you're still not understanding, just go ahead and keep playing this through and follow along and see if you can follow the work. Okay, so let's see how well you did. Let's multiply these together. So I have the fifth root of 8x squared times the fifth root of 4x to the 8th. This one's easier to do in our head. Again, they have the same root, so the root's going to stay the same. It's going to be the fifth root. 8 times 4 is 32 x squared times x to the 8th. Remember, when you're multiplying and the bases are the same, we add the exponents. 2 plus 8 is 10. So it'll be x to the 10th. Okay, now we want to simplify this. I want to figure out what times itself 5 times and give me 32. Well, if you don't know what that is, we're going to have to do a factor tree. So we look for any two numbers that multiply together to give me 32. Now we could use 8 and 4 if you want. Or we could have used 2 and 16. There's a bunch. We could have used 4 and 8. We could have used 16 and 2. Now 8 factors down to be 2 times 4. And 2 is a prime number. And 4 factors down to be 2 times 2, and both of those are prime numbers. Go over to this 4, don't forget about that one. It's not circled, so that means that we're not done with it. So now if you notice, the ends of this tree, everything's circled. That means everything's a prime number, and I have 1, 2, 3, 4, 5 2's. So remember, I said what times itself 5 times give me 32? Well, it would be 2. How many times does 5 go into 10? 5 goes into 10 2 times. So my answer would be 2x squared. There's your answer. Let's look at some other examples. We want to simplify this expression. So I have the cube root of 64, r to the 6th power, times s to the 15th power. We don't have to do any multiplying here. One thing you could do, though, to maybe to make it a little easier, is break this apart. Kind of like what in this box, what it was saying is if I have it all under one radical, I could break it apart into pieces if you want to make it easier. So here I have the cube root of 64 times the cube root of r to the 6th times the cube root of s to the 15th. Now we're going to simplify each of these pieces. The 64 breaks down into a number of different things, but 8 times 8 stands out, so I'm going to do 8 times 8. Now we just realized that 8 simplifies to be 2 times 4, and 4 simplifies to be 2 times 2. The more you do these, you'll recognize some different numbers. 8 is just one of those, where it works out to be 2 times 2 times 2. So if you want to skip some steps to make it easier, you can do that. So I just found that 64 works out to be 2 times 2 times 2 times 2 times 2 times 2. Notice I have 6 2's here. Well, this is the cube root of 64. So what that means is for every 3 the same number, I get to take one out. So I get to take out a 2 representing these 3 2's. I get to take out another 2 representing these 3 2's. Okay, that's what the cube root of 64 breaks down to be, is 2 times 2, or 4. The cube root of r to the 6th, well, 3 goes into 6 2 times, so that's going to be r squared. 6 divided by 3, remember we take the power divided by the root. So our answer is going to be 4r squared. 3 goes into 15 evenly 5 times, so it'll be s to the 5th. So our answer is 4r squared s to the 5th. Why don't you try that now on your own with the cube root of 125, a to the 12th, b to the 27th. So pause the video and play it when you're ready. Okay, with this one, I'm going to break this up into the cube root of 125 times the cube root of a to the 12th times the cube root of b to the 27th. And I'm going to simplify each of these. Now you may know what the cube root of 125 is, but if you don't, do the factor tree for it. Each of these are prime. So I have the cube root of 125. Well, it means for every 3 the same number, I get to take one out. Well, I have 3 5's here, so I'm going to take out a 5. So my answer is going to be 5 times the cube root of a to the 12th power. Well, 3 goes into 12 4 times, so it'll be a to the 4th. And 3 goes into 27 9 times, so that will simplify to be b to the 9th. And there's your answer.